as like as earlier case, but only the difference is the plane surface submerged. Suppose earlier case the plane surface is submerged like this vertically. Now instead of vertically the plane surface is submerged like this, some angle. Earlier this is the 90 degrees angle with the free surface. Now the plane surface is submerged like this. This is 90 degrees with the plane surface. Now this is some theta. That plane surface is immersed in the liquid like this. That the angle is theta. That is only the difference here. The surface is inclined. Right, let us consider the plane surface arbitrary shape immersed in liquid in such a way that plane surface makes an angle of theta. This is the plane surface makes an angle of theta with the free surface of the liquid. Right? Only the difference is earlier case, this is the plane liquid, this is the liquid surface, this is the arbitrary shape. Please listen. So here this is the CG of the plane surface. Now this is denoted by H bar. Now this is the point of application of total pressure. This is denoted by H star, that is the center of pressure. We have taken one small strip like this. The distance from the small strip to the free surface is taken as H. If the plane surface is immersed vertically in the static fluid. But now this is the different. The plane surface is immersed in liquid in such a way that that makes an angle theta with the free surface. Now we are going to take one axis, that is 0, 0, 0, 0 is the one axis. Suppose this is the plane surface. Initially we have submerged like this. Now we have submerged like this. Now say this is the 0, 0, point 0, 0 to point 0, 0. This is the strip. Earlier case with respect to free surface. Suppose now we are going to assume that this is the with respect to free surface. Instead of free surface, we have taken 0, 0. Okay. Now this is the strip we are going to take. The depth is equal to dh. That is y distance from the 0, 0, and this is the CG of the liquid, that is y bar distance from the 0, 0. This is the center of pressure, that is y star distance from the 0, 0. These are the differences as compared with the earlier one. Earlier case we have directly have H bar, H star, but now we are not directly have the H and H star and H bar. But based on this figure we are going to develop the H star, H bar and H. Right? This is a diagram here. Let us consider the following data from the above figure. From that figure, A is the A equal to total area of the inclined surface. This is the total area of the inclined surface is capital A. H bar is the height of center of gravity of the inclined area from the free surface. This is H bar. H star is the distance of center of pressure from free surface of liquid. This is the center of pressure. So this is the H star is the distance between the point of center of pressure to the free surface. Right? These are the terms, and also theta is angle made by the inclined plane surface with the free surface of the liquid. Theta is angle made by the inclined plane surface with the free surface of the liquid. This is theta. Right? 0, 0 is the axis perpendicular to the plane of surface. This is the plane of surface. Perpendicular to the plane of surface. 0, 0 is the axis. Please listen carefully. Right, next point. Let y bar is equal to distance of CG of the inclined surface from 0, 0. From 0, 0, this is y bar. Y bar is the distance from 0, 0 to CG. Next, y star is the distance of center of pressure from 0, 0. This is the distance of center of pressure. This is y star. Next one, y is the distance from, this is the free strip. As like as earlier case, we are going to take the one small strip, that is y distance from the 0 0. Right, the strip area, strip depth is equal to, area is equal to dA, depth is equal to dy. Dy is the depth. Right, now from this one, sin theta equal to, sin theta, suppose we are going to take this one and this one. Right, this is equal to h bar, this is theta, this distance is nothing but y bar. Okay, now sin theta equal to, sin theta equal to opposite side h bar divided by hypotenuse, that is y bar. Okay, please remember these points are very very important. Another one, again, now we are going to take this point, this is the, this point and this point. This is nothing but h star and this is nothing but y star. Here also sin theta equal to opposite side h star divided by hypotenuse, that is equal to y star. Like that, sin theta equal to, sin theta equal to, this is the y, now this is h. Okay, sin theta is equal to opposite side h divided by y. These 3 points are different as compared with the earlier derivation. Sin theta equal to h by y, sin theta is equal to h bar by y bar, sin theta is equal to h star by y star. Right, now this is the equation. Now h is equal to y sin theta, h bar is equal to y bar sin theta, h star is equal to y star sin theta. These points we are going to remember. Right, next one, same steps. First we are going to determine the total pressure if the plane surface immersed in liquid in such a way that that makes with an angle theta with the free surface. Now pressure intensity, same steps what we have followed in the earlier case, same steps here also we are going to follow. That is equal to pressure intensity equal to, that is equal to W into H. Weight, unit weight into H, that is equal to, unit weight is also nothing but rho g into H. But here H is also nothing but what? H is equal to, if the surface makes an angle theta, therefore H is nothing but rho g y sin theta. This is the pressure intensity over the strip. This is the pressure intensity, P is equal to rho g H. Rho g h, h is nothing but y sin theta. Already I have explained in the earlier slide. The pressure force on the strip, pressure force on the strip dF is equal to, pressure force equal to stress into area, intensity of pressure into area. This is equal to intensity of pressure rho g y sin theta into area is nothing but to B dH. Right, now this is the pressure force on the strip. Now the pressure force on the entire plane surface, the pressure force on the total surface, that is equal to F is equal to integral rho g y sin theta into B dH. Now rho g sin theta taken out, therefore F is equal to rho g sin theta integral y b dH. Right, now this is equal to, now already integral y b dH is also nothing but, integral y b dH is the moment of area about the axis OO, moment of area about the axis OO, because this is y not h. Integral y bh is the moment of area about the axis OO. Therefore this is also nothing but area, moment of area into about the axis y bar. Right, y bar. Therefore force is equal to, therefore force rho g sine theta into, in this place, integral y b dh. This is also written as integral y dA. Y dA is the moment of area about the axis OO. Therefore, in this place, area into y bar, right, into a y bar. Right, now rho g sine theta a y bar. But here y bar is also nothing but already I have given. Y bar is equal to what? H bar is equal to y bar sine theta. Y bar is equal to h bar divided by sine theta. H bar divided by sine theta. In place of y bar, h bar divided by sine theta. F is equal to rho g sine theta into a. In place of y bar, we are going to take h bar by sine theta. H bar by sine theta. Sine theta gets cancelled. Therefore, force F is equal to rho g a h bar. Right, this is the total force acting on the plane surface that is immersed at an angle theta with the free surface is equal to F is equal to rho g a h bar, or F is equal to W A h bar, where W is the unit weight of water, A is the surface area of the plane, h bar is the distance between the center of the, this is the center of the objective to the free surface, that is distance h bar. Right, now we are going to determine the center of pressure. The center of pressure is determined by using the principle of moments. It states that the moment of resultant force is equal to the sum of the moment of the components at the same axis. Right? Now, the resultant force F acting at P at a distance h star from the free surface of the liquid. Right? This is the diagram already I have explained regarding this diagram. Now, moment of the force F about OO. Moment of the force about OO is equal to F into y star. Because this is the make an angle with the theta. Therefore, F into y star. F is the resultant force. Y star is the distance of the center of pressure to the axis OO or to the surface OO. Moment of resultant force equal to force into y star. Moment of resultant force F into y star, this is about 0 0 axis, about the axis of 0 0. Right? Now, moment of force dF acting on the strip. Moment of force dF, acting on the strip is equal to, what is the force? Stress into area. Stress rho g y sine theta. This is the stress into area is dA. Moment of force on the strip dF is equal to rho g y sine theta into dA. This is the force dF. Movement means into y. Right? Therefore, this is equal to rho g y square sine theta into dA. Now, this is the moment of force on the strip dF. Now, sum of the moment of all these forces over the entire area, sum of the moments of all these forces is equal to integral rho g y square sine theta into dA. Now, rho g sine theta taken out from the integral, that is equal to integral y square dA. Rho g sine theta taken out from the integral, therefore integral y square dA. But the term integral y square dA, now the term integral y square dA is the moment of inertia about the axis OO. Moment of inertia about the axis OO. Right? This is denoted by I0. Right? Therefore, rho g sine theta into I0. In place of integral y square dA, we are going to take the I0. I0 is the moment of inertia about the axis OO. Right? This is the equation number 2. Already we have derived equation number 1, that is the moment of resultant force. That is moment of resultant force is equal to F into y star. This is equation number 1. Now, equating these two equations, equation number 1 and equation number 2, finally we have the center of pressure, that is the distance between the point of application of total pressure to the free surface. Right, now equating these two forces, right, principle of momentum states that the moment of resultant force is equal to the sum of the moments of the components about the same axis. Based on that statement, we are going to equate the equation number 1 and equation number 2. Right? Force into y star is equal to rho g y sine theta into I0. Right? Force is equal to rho g a y bar, no, rho g a h bar. This is the total resultant force into y star equal to rho g y sine theta into I0. Rho g gets cancelled. This is equal to a h bar y star is equal to y sine theta I0. So y is sine theta I0. Now y star is also nothing but, here h star is equal to y star sine theta, y star is equal to h star divided by sine theta. Right? Therefore, a h bar into, in place of y star we are going to take h star into sine theta. H star divided by sine theta. Sine theta. Therefore, this is equal to sine theta I0. Right? Therefore, h star is equal to sine square theta I0 divided by a h bar. H star is equal to sine square theta I0 divided by a h bar. Right? Right, we have the equation h star is equal to sine theta I0 divided by a h bar. But based on the parallel axis theorem, I0 is equal to ICG or IG plus AY bar. I0 means that is the moment of inertia about the axis OO is equal to ICG is the moment of inertia about CG, and y bar is the distance of CG to the point OO. Right? In place of I0 we are going to take ICG or IG plus AY bar square. Right? Therefore, H star is equal to sine theta. I0 is nothing but ICG plus AY bar square divided by AH bar. Okay. Now, AY bar square and Y bar is also nothing but, from this equation, H bar is equal to Y bar sine theta. Therefore, Y bar is equal to h bar divided by sin theta. Y bar equal to h bar divided by sin theta. In place of y bar, we are going to take this value h bar divided by sin theta. This is equal to sin theta ICG plus sin, this is sin square theta. Sin square theta, sin square theta, sin square theta into ICG plus sin square theta into A into, in place of y bar square, we are going to take y bar. In place of y bar, h bar divided by sin theta. That is h bar square divided by sin square theta, right, divided by a h bar. Now sin square theta, sin square theta gets cancelled. Therefore, h star is equal to sin square theta ICG plus a h bar square divided by a h bar. Right? Now, this is equal to sin square theta ICG divided by a h bar plus a h bar square divided by a h bar. Square h bar cancel, a cancel. Therefore, h star is equal to right, h star is equal to sin square theta ICG divided by a h bar plus h bar. This is the formula for the determination of center of pressure, distance of center of pressure if the plane surface is immersed inclined in the static fluid. Right? Now, in place of here sin square theta, suppose if theta is equal to 90 degrees, sin theta is equal to sin 90 is equal to 1. Therefore, this is equal to sin 1 square is equal to 1. Therefore, h star is equal to ICG divided by a h bar plus h bar. This is the formula. If theta equal to 90 degrees, the equation represents that the plane surface immersed in liquid is vertical position. That means in case of vertical position, distance of center of pressure h star is equal to ICG divided by a h bar plus h bar. Right? This is the equation for the determination of total pressure and center of pressure. Now, we are going to discuss about a curved surface immersed in the static fluid. What is the total pressure? What is the center of pressure? Right here, say here, consider a curved surface AB submerged in static fluid. This is the curved surface AB, submerged in static fluid. Right? Let dA is the area of the small strip at a depth h from the free surface. This is the small area dA, is the area of the small strip, that is h distance from the free surface. Then pressure intensity on the area dA, pressure intensity is equal to WH. W is also nothing but rho g, mass density into acceleration due to gravity into h, that is the h distance from free surface to the center of the small strip area. Right? This is equal to rho g h is the intensity of pressure. Now, pressure force dF, that means pressure force on the small strip equal to stress into area. Stress is nothing but rho g into h is the stress or pressure or intensity of pressure into area is dA. Right? Now, the total pressure on the curved surface. But earlier case we have taken the total pressure on the inclined surface, the total pressure on the vertical surface is integration of the pressure on the strip. We have the total pressure on the vertical surface, entire vertical surface. But here that is not applicable, because the total pressure the total pressure on the curved surface, generally in the earlier case, integral rho g h dA. This is the formula we have used in the earlier case because that is vertical plane. But here, that integration of these total force on the small strip not gives the total pressure force on the entire area because force on the small area are not in the same direction but varies from point to point, right? The pressure force on the small area, this is the small area. The pressure force on the small area is not distributed equally, that is varies from point to point, are not in the same direction. The pressure force is not in the same direction because this is the curved portion. This is varies from point to point. Now we are going to determine the total force on the curved surface by using another technique. That is resolving the force dF in two components. Already we have determined the pressure force on the strip dF is equal to rho g h dA. First, resolving the force dF into two components, that is dFx and dFy, then the total force on the xy directions is determined, that is Fy and Fx. First, the total force on the strip dF is resolving into two components, that is dFx and dFy. Then the total force on the element or the total force in the x direction Fx and total force in the y direction Fy are going to determine. Right now, in this context, first resolving the force dF in x and y directions. Please see the diagram here. This is the curved portion. This is the x direction. This is the y direction. This is the force dF. Right? This is force dF, this is force dF, this is equal to dFy, this is equal to dFx. Okay, now this is the theta, right? From this theta, this is also nothing but dFx. Now sin theta is equal to this is theta, sin theta is equal to opposite side is nothing but dfx divided by hypotenuse is nothing but df. Therefore dfx is equal to df sin theta. Dfx means the component of total pressure force on the strip, that is in the x direction, dfx is equal to df sin theta. Similarly cos theta is equal to adjacent side, that is equal to dfy divided by hypotenuse, that is equal to df. Therefore dfy is equal to df cos theta, right? dfx is equal to df sin theta, this is determined, and dfy is equal to df cos theta, this is also determined here. Now we are going to determine the total pressure force in x and y directions. Now we are going to determine the total pressure force in x and y directions. Total pressure force in x direction is equal to stress into area, right? Fx. Total pressure force in the x direction is equal to integral dfx, right? This is equal to integral dfx is also nothing but df sin theta, right? Already we have determined df is equal to, this is equal to rho g h into dA. This is df is equal to rho g h into dA into sin theta. This is the total pressure force in the x direction, that is equal to rho g sin theta, rho g taken out, integral h sin theta dA, right? This is equal to rho g integral dA sin theta h. This is the equation we have. This is the total pressure force in the x direction. right? Now, similarly, the total pressure force in the y direction Fy is equal to the total pressure force in the y direction Fy is equal to integral dFy. This is equal to dFy. dFy is nothing but dF into cos theta. Right? This is equal to dF already we have determined, that is equal to rho g h into dA dF into cos theta. This is integral. Now here also we are going to take rho g out from the integral. Therefore this is dA cos theta into h. This is the equation. The total pressure force in the y direction is equal to rho g integral dA cos theta h. Okay. Right. From this figure, this is one small strip here. From the figure, the enlarged cross-sectional area, this is dA. This is EG is the dA cos theta. This is FG is the dA sin theta. From the diagram, Fg is equal to dA sin theta. Fg is nothing but the vertical component, that is equal to dA sin theta. Therefore, that is vertical projection of area dA. And EG is equal to dA cos theta. EG is equal to dA cos theta. This is nothing but a horizontal projection area of dA. Right? Now, already we have derived total pressure force in the x direction is equal to rho g integral h dA sin theta. dA sin theta is nothing but vertical projection of area. Right? dA sin theta is equal to Fg, that is equal to vertical projection of area dA, and hence this expression rho g integral h dA sin theta represents that the total pressure force integral rho g integral h dA sin theta represents that the total pressure force on the projected area of the curved surface on the vertical plane. Fx is nothing but the total pressure force on the projected area of the curved surface on the vertical plane. Now we are going to take the total pressure force in the y direction. Total pressure force Fy in the y direction, that is the formula already we have derived. That is, this is the formula. From this diagram, we know EG is equal to dA cos theta. dA cos theta represents horizontal projection of the area. Right? Now EG is equal to dA cos theta, that is a horizontal projection of area. This is the horizontal projection of area, and integral h dA cos theta represents volume of liquid. Integral h dA cos theta represents volume of liquid contained in the elementary area dA up to the free surface of the liquid. Therefore, hence integral rho g integral h dA cos theta is the total weight supported by the curved surface. Therefore, hence rho g integral h dA cos theta is the total weight supported by the curved surface. Right? Therefore, Fy is also nothing but weight of liquid supported by the curved surface up to which the free surface. That means this is nothing but weight of liquid supported by the curved surface. This is the curved surface. Weight of liquid supported by the curved surface up to which the free surface. This is known as the Fy. Right? Last point. We are going to remember these 2 points where we are going to solve the problems. We are going to remember these 2 points where we are going to solve the problems if the curved plane surface is immersed in the liquid. The first point, Fx is nothing but what? Fy is nothing but what? Fx is the total pressure force on the projected area of the curved surface. Fx is the total pressure force on the projected area of the curved surface on the vertical plane. Next one, Fy. Weight of liquid supported by the curved surface up to the free surface. These 2 points very, very important. And last one, the total pressure force on the curved surface. The total pressure force on the curved surface, just we have derived the total pressure force in the x direction. and also we have derived the total pressure force in the y direction. Therefore total pressure force on the curved surface is equal to square root of fx square plus fy square. Fx square is the total pressure force in the x direction, fy square is the total pressure force in the y direction, right? Last one, inclination of the resultant of force with horizontal. Inclination of resultant force with horizontal, tan pi is equal to fy by fx. This formula is used where we are going to solve the problems related to the plane surface, curved plane surfaces immersed in the liquid. Okay, thank you one and all.